Hi guys, so today I want to teach you about the Fourier series, what it is, how it works, and why we need it. So now the first thing I want you to note is Fourier series only works on periodic functions. So if the function is not periodic, forget about it. Fourier series can't work on it. If you don't know how to identify a periodic function, link below in the description. So we have a periodic function like this. What the Fourier series does is that it decomposes this function down to a bunch of harmonics. So we can have our first harmonic, third harmonic, fifth harmonic. Now you'll notice that there are only odd harmonics here. This is because this square wave is an odd function and odd functions only have odd harmonics. I explained that more in details, odd and even functions below in the description. So now you notice the frequency components of each harmonics is different. The first harmonic completes one cycle per second. This completes three cycles per second, and this completes five cycles per second. So this increase in frequency is something that's very notable between the harmonics. Something kind of amazing happens when you then add up these harmonics. It is able to reconstruct the original periodic wave accurately, and the more harmonics you have, the more accurately you're going to be able to get the original periodic function. Now, the second question I want to answer is why do you then need these harmonics? Have you guys ever really listened to Twinkle Twinkle Little Star and the alphabetical song? Almost the same soundtrack. And if you give this to a model at face value, the model might not really be able to differentiate the songs apart, especially for like music recognition models like Shazam. So, but if it's able to break this down into harmonics which have distinct frequency components, it is able to give each song a unique fingerprint whereby it can compare it with this huge database and be able to actually pinpoint the specific song. Like for example, when you're singing the alphabetical song, when you get to LMNOP, you have to be a bit faster, which means the frequency is higher there. But for Twinkle Little Star, it's Twinkle Twinkle Little Star, How I Wonder, very coordinated. So that difference will be picked up by the model. And the last question we should now be asking is how do we then get this harmonic since we understand what we're using it for? This is where the Fourier equation comes in. The Fourier equation is given by this formula over here. As you can see, it's a lovely formula. Castle this part. And to take the sum from n equals to 1 till k equals to 3, that is 1, 2, 3. Replace it at this point n, replace it 1, 2, 3. We're going to get this sum, which in this case, the first harmonic is going to be a1 cos x plus b1 sin x, the second harmonic a2 cos 2x plus b2 sin 2x, and the third harmonic as follows. And you can keep going fourth, fifth, sixth, so wherever you want to stop, like do you. So this basic breakdown of how the Fourier series works and what it's doing to periodic functions. Please like and subscribe for more comprehensive explanations like this. Welcome.